Good morning to all of you. Myself, Professor N.V. Arpe from SND College of Engineering and Research Center, Yola. Now, uh, in that video, that is in that lecture, we are discussing the static and dynamic characteristics of measuring instrument. What is measuring instrument? First, the instrument which is used to measure the electrical quantities like voltage, current, power, resistance, all the types of electrical parameters. The performance characteristics of any instrument, performance characteristics of any instrument, it will be divided into two parts. It will be mainly divided into two parts. That is, first one is static characteristics and second one is dynamic characteristics. In that, there are many characteristics. First, we are discussing the one by one. First, static characteristics. The set of criteria defined for the instrument which are used to measure the quantities which is slowly varying with time or mostly constant, that is, do not vary with time. It is called as static characteristic. Means the characteristics of any instrument which is not depends on your time varying quantity. Means as the time increases or decreases, the value of any quantity will be decreased, will be changes. This will be not considered in a static characteristics. Then the various static characteristics are: first one is accuracy, precision, sensitivity, linearity, reproducibility, repeatability, resolution, threshold, drift, stability, tolerance, range, and span. Range or span. These are the your static characteristics. First one is accuracy. It is the degree of closeness with which the reading approaches the true value of the quantity to be measured. It is the degree of closeness with which the reading approaches the true value of the quantity to be measured. That is the value which is shown by the meter, which is near to the accurate value or exactly the accurate value. It is called as accuracy. The, this accuracy again divided into three sub points. That is point accuracy, accuracy as a percentage of scale span, and accuracy as a percentage of true value. First one is point accuracy. Such accuracy is specified at only one particular point of scale. Only one particular point of scale. It does not give any information about the accuracy at any other point on the scale. Means this only use this point accuracy means only the accuracy at a point which is given on the scale of the meter. Second, accuracy as percentage of scale span. When the instrument has uniform scale, its accuracy must be expressed in terms of scale range. Suppose a 1 meter is take a given a scale that is 0 to 5 ampere. Then the accuracy as a percentage of scale span, it will be expressed in terms of scale range, that is 0 to 5 ampere. Then third one is accuracy as percentage of true value. Again, the best way to convince the idea of accuracy is to specify it in terms of the true value of the quantity being measured. Means the accuracy of any instrument, it will be uh, compared with the true value, with the exact value of the quantity. Second, this is your accuracy as a percentage of true value. The second characteristic is precision. Precision, it is the measure of reproducibility, that is given a fixed value of a quantity. Precision is a measure of degree of agreement within a group of measurement. Within a group of measurement means the the instrument uh, gives the value, repeat again and again, same value. This is called as precision. It will be composed into two characteristics. First one is conformity and second is number of significant digits. First one is conformity. Consider a register having two value of 2385692, which is being measured by an ohm meter, but the reader can read constituently a value of as 2.4 mega ohm due to the non-availability of product scale. The error created due to the limitation of the scale reading is as a precision error. Means as means this is a digital meter, and if the meter showing the scale only one decimal point up, one significant digit after the decimal point, then due to that the error will be caused. This is called as precision error. This is your conformity. Next one is number of significant figures. Means the after the decimal point, the number of significant digit, how much significant digit we are considering, this is your number of significant figures. Next one is sensitivity. The sensitivity denotes the smallest change in measured variable to which the instrument responds. It is defined as the ratio of changes in the output of the instrument to a change in value of the quantity to be measured. That is sensitivity. Means suppose as the smallest change in a measured value, suppose we measure the current in a system. Suppose small current, very small, that is 0.01 ampere current will be changed. And then the uh, by this smallest change, the instrument should be respond. Instrument should be respond to give the value or to give the reading. It is called as sensitivity, and it is defined as the ratio of changes in output to the output of an instrument to the change in the value. Means the output means the reading shown by the meter, and input is the current changing value, and it will be mathematically expressed as infinite infinitesimal change in output upon infinitesimal change in input, that is delta q0 upon delta qi. This is your the graph of the sensitivity. As some change in input, the output will be changed. This is your sensitivity. Next one is linearity. The linearity is defined as the ability to reproduce the input characteristics symmetrically and linearly. The curve, the actual calibration curve is idealized straight line. Means as the input is changes in some same proportionally, the output will be changed. That is your straight line. This is called as your linearity. But the actual reading is like that. The actual reading is like that. This is your deviation. This is your deviation in a graph. This is your linearity. Next one is your reproducibility. It is the degree of closeness with which a given value may be repeatedly measured. Means again and again, same reading should be occurred. It is specified in terms of scale reading over a given period of time. Over a given period of time. This is your reproducibility. Again, repeatability. It depends as the variation of scale reading and random in nature. In random in nature. Means the variation of scale reading. It is called as repeatability. Next one is drift. It will be classified into three parts. First one is zero drift, span drift, and zonal drift. The zero drift means if the whole calibration gradually shifts due to slippage, permanent set, or due to under warming up of electronic tube circuits, zero drift setting means as this is your characteristics with zero drift and this is your normal characteristic. Means both the lines are parallel to each other, then it is called as zero drift. This is your span drift. There is if there is proportional change in the indication all along the upward scale, the drift is called as span drift. Means as the input changes and according to that the span will be changes. The span will be the drift will be changes. This is called as span drift. And the zonal drift, in this case of drift, occurs only a portion of span of an instrument. It is called as zonal drift. Next one is resolution. If the input is slowly increased from some input value, it will again be found that output does not change. Output does not change at all until a certain increment is exceeded. This increment is called as resolution. Means up to some value changes, input value changes, the output does not change. It is called as resolution. It is called as resolution. Again, threshold. If the instrument input is increased very gradually from zero, there is some minimum value below which no input change can be detected. This minimum value is called as threshold value. Means after that input, the output will be changes. It is called as threshold. Stability. If the ability of an instrument to retain its performance throughout its specified operating life, it is called as stability. The tolerance, the sum permissible error, the sum allowed error or maximum allowed error in the instrument, it is called as tolerance. Next, range or span. The minimum and maximum values of the quantity for which the instrument is designed to measure, it is called as its range or span. Suppose one instrument we have taken, that is ammeter, having range 0 to 5 ampere, then it is the range 0 to 5 ampere. This is your static characteristic. Now dynamic characteristic. The set of criteria define the instrument which are changes rapidly with time. The characteristics of instrument which will be depends on your time. It is called as dynamic characteristic. There are four dynamic characteristics. First one is speed of response, measuring lag, fidelity, and dynamic error. First one is speed of response. It is defined as the rapidity with which a measurement system responds to change in the measured quantity. Means the response means as the input is changes, the speed of response, output response changes. It is called as speed of response. Second one is measuring lag. It is the retardation or delay in the response of the measuring system to change in the measured quantity. Means there is some delay in your output. This is called as measuring lag. These are two types, retardation type and time delay lag. Retardation type, in this case of response, the measurement system begins immediately after the change in measured quantity has occurred. Means as the input is changes, the output will be changes accordingly that immediately. Again, time delay lag. In this case, the response of the measurement system begins after a dead time after the application of the input. Means there is some time delay lag. The last one is dynamic error. It is the difference between the true value of the quantity changing with time and the value indicated by the measurement system. If no static error is observed, it is called as measurement error. Called as measurement error. This is your static and dynamic characteristics of measuring instrument. Okay, so stop here. Thank you.